Okay, I'm going to try to go through this paper 2 calculus question on the practice test. People still seem to be having troubles and kind of take you through the thinking. Okay, so it's worth scanning the problem. They repeat some different concepts. This one gives you a function. We don't know what the value of k is, but usually that means you're going to have to find it. So just pretend that you already know what the value of k is, because they told you that. And you can put that in your calculator as with the 3 there, okay? So the other thing is that there's going to be a window for graphing down here. So I've already put that in my calculator with the x going from -5 to 10 and y from -10 to 100, just because I know I'm going to use that. Having a little bit of a plan might save a little time. All right, so let's work through these, try to show you on this paper so you can see how to work it out. Write down the derivative. That's straightforward, just like we did in class. Notice I wrote the function as a negative exponent already, so this is -192 x to the -3. And people get thrown off by this constant thing. If there was a 7 there, the derivative of 7x would be 7. There's a k there, so it's just plus k. Check for A. B, the graph of f of x has a local minimum at x equals -4. This is where your definitions come in. A minimum means that the derivative is 0. So f prime equals 0 at x equals 4. So I'm just going to go to my derivative equation. 0 equals -192, 4 to the -3 plus k. 4 to the -3 means 1 over 4 cubed. That's 64. I'm doing this a little faster because I worked it through already. Okay, but you could do the rest on your calculator. K equals 3. I did the show that part. Okay, now what's coming up next? Mostly tangent lines, maxes, and mins. So they're leading you into, they're saying find f of 2 and find f prime of 2. If you notice, I have labeled f and f prime. Don't just write those things on your paper. You don't know which one to plug it in. So they're leading us into this question of either finding the derivative or the tangent line or the normal. So f of 2, that's my y coordinate. Every line needs a point. Every line needs a slope. So they're helping us find our point. We know that the x coordinate is 2. We can plug into f of x to find the y coordinate. If you want, you could put this in your table. I recommend it. We know k is 3. You could have skipped that k problem and gone on and done this right here anyhow. Okay, so when I plug that in there, I'm going to go to my table, see what's there. At x equals 2, y equals 30. So I have the point 230. And then they're asking you to find f prime of 2, which is the slope of the tangent line at 2. So I'm going to plug in -192, 2 to the third, to the -3rd, plus 3, because k was 3. And that's going to be my slope. -192 over 8 plus 3. 192 divided by 8 is 24, -24 plus 3. F prime of is -21. So I know I have my slope of -21, and I have a point 230. At this point, they can either ask you to find the normal line or the tangent line. If it's the normal line, y equals mx plus b, just plug in and go. Or sorry, if it's a tangent line, you plug in and go. It's the normal line. And they say put it in this form. That's what all this mumbo jumbo is. So y equals mx plus b. I'm now on part. I didn't label my parts over here. So that's C, that's D. Here's E. Y equals mx plus b. I know my slope, if it was a tangent, is -21. It's not a tangent. It's a normal. So I do the opposite reciprocal. And I plug in my point. Turn into an algebra 1 problem. So 2 over 21 plus b equals 30. So b equals 30 minus 2 over 21. If you want, you can use your calculator. 30 minus 2 over 21. And then frac it. Math, frac. 628 over 21. So the equation of my normal line then, y equals 121 plus 628 over 21. I would give points at this point, but I need to put it in that form where I have all integers and everything's on one side of the equation. So I'm going to multiply this whole thing by 21. So I have 21y equals x plus 628. Bring everything over. Now it's set equal to 0. Okay, so I keep going. Next question. Sketch the graph. I'm not going to do that on graph paper. I'd label the axes though, but if you will notice, I did change my window to match the window so I can see the graph. And I would sketch it, and you make sure when you sketch it, you make sure that the minimum point is clear, which they told you is at x equals 4. Make sure that is labeled, and you make sure this point's labeled. Other than that, you need to have a little bit of a scale, but you don't need to put every number on there. Okay, that's F, and you put F on the graph paper, and you know this is question 5, so you label this 5F and make your graph. They don't give you a scale you have to use, so you can pick your own. Okay, write down the coordinates of the point where the graph y equals f of x intersects the x-axis. That is the x-coordinate right there. And you go to your table and find it. Looks like -3. It's not. It's not an exact value, so you have to calculate it. You calculate the 0. I'm going to go on the left side of it, which is I'm going to enter a -4. You can move the arrow if you want. And then I'm going to go past it. And then land on it. -3.170. So G, -3.170, because it says coordinates. Always look for the form and you put your answer. The last question, now I did this is going to be less than 10-minute video. I didn't graph, so you'd have, however many points there are, you'd have that many minutes. State the values for which f of x is decreasing. That means decreasing means negative slope. So negative slope starts here at 0 and goes all the way to my minimum point, which they already told me was at 4. So you could write it like this. Probably write it in words. As long as you say between, we're not including those values, and then you have it. Okay, so a couple things to note. Don't ever enter your derivative in here unless it's something you need to substitute. You always want to look at the graph of the function. You can use your function to calculate stuff. Just plug things in and show it. Okay. So in calculus, there's kind of two things. There's the tangent normal line problem. Starts by finding the derivative. And there's the max min, increasing, decreasing, and optimization, which is finding max and min. For those, you're going to set the derivative equal to 0 so you know where there is no slope, and then you find your boundaries. Okay, so hopefully that helps you a little bit with calculus.